So, hello and welcome. I don't know who I am, but you've seen me in such fine quality epic chemistry educational videos, and I can't remember what they are right now. But here we got to look at, for APES, AP Environmental Science, we're looking at a Chapter 4 supplement that they don't talk about in the book, but I do feel it's an important part of environmental science, and that's the theory of island biogeography. So if you're looking at communities, we've talked about the idea of richness and relative abundance, okay, where we can talk about how many species, different species we have compared to how abundant are they. And that's a key thing there to look at. So what we've got to look at is the theory of island biogeography. What in the world is going on? What's happening with that? So if we look at biogeographical changes here, if you're looking at the species richness, if you're taking this down here to be the equator as you're going up, with some exceptions here and here, the general trend is that the number of species as you're going from the equator toward the polar ends of the planet, it's going to decline. But why in the world is that happening? Well, one of them is dealing with the climate. If the climate is getting colder, there tends to be fewer species out there because not that many have adapted to the cold. And then you can talk about the evolutionary history about that as well. But that's not really our thing. We need to talk about the idea of islands, okay? How in the world did the species get there onto the islands away from the main continent? And that's what we're looking at. And if we were to look at the basic concept, okay, of a species area curve, where here you have the number of species and here you have the number of acres. And this really shouldn't be a big surprise because we're looking at a particular species of bird in this case, and our data points show us roughly the area of the island in terms of acres and how many different species that we have. And what you're seeing here is the general trend is the bigger the island, the more number of species that you're going to get. So the smaller size of the island, the smaller number of species that you're going to have, which kind of makes sense for that. Okay, but there's a couple of things, and there's some key things that we have to look at. We have to look at how much immigration is happening on the island and how much extinction is happening on the island. These are things that happen at the same time. Now, with that, this is true for any place on the earth. If you stop and think about it in an area, whether it's the San Bernardino Mountains or the Sierra Nevadas or Catalina Island or the Hawaiian Islands. Okay, so you look at immigration and extinction, but there's a couple of other factors you have to look at. One, the island size. Now we've already established that the bigger the island, the more species you're going to have. Okay, but the other factor is how far from the mainland is it? Okay, because if you stop and think about it, the farther away the island is from the mainland, is it going to be easier or harder for species to get there? It's going to be harder. Absolutely. Okay? Now, how is it that the species actually get there? There are different ways depending on what species you are. Okay? Humans, accidental and intended. Okay? A great example, Hawaiian Islands. You might want to possibly write that one down. How the rats were introduced to the Hawaiian Islands was when the British Captain James Cook landed there way back in the 1700s. The Hawaiian Islands did not have any rats. There were a few rats on board the ship. Ship laid anchor. The rats walked along the chain of the anchor and they swam to the shores. They had no competition and they outcompeted the natives. And that's a real problem because in Hawaii, a lot of the palm trees, you're going to see a metal band around it to prevent them from scurrying up and making nests in the trees or eating the seeds. So animals like sticky seeds and scat, okay, that's how some species will go through, okay. Wind and ocean currents. This could be a positive or a negative, depending on that. Land bridges. There can be land bridges that come from the mainland to the island, okay? A great example of that would be Alaska, that at one time there was a land bridge from the very northern part of Asia crossing over into Alaska, okay? That bridge is not there now, okay? But it was there at one point. So we can talk about stepping stone islands, okay? And what's happening there? Well, some of them can be affected by climatic changes like glaciation. Think about the Ice Age coming in, glaciers. That's what we mean by glaciation. Ocean levels, short-term weather patterns. All those things affect, okay? So what is allowing the colonization? Well, I kind of gave you some clues with the rats. You have a niche opening. Okay, so you already have a chance for the animal or the species to survive. The other thing is you don't have competition. That's a big one. Okay, or if it's no competition, they outcompete the natives. And that happens a lot. The endemics, not utilizing the resources. Endemics, the first thing that should come in your mind are natives. Native species. Okay, that's a really important term to know. So our natives are not using all the resources available to them, okay? And of course, accessibility to the colonists, which we like to call the invading species. If they have the access, go for it. We've done it again and again and again. So here's the idea. When we look at the theory of island biogeography, the immigration rate goes down as the island diversity goes up. So if you have if you have a nice diversity on the island, there's going to be the immigration rate is going to go down because you already have a number of species on there. However, you also have extinction that's going to go up. And when we talk extinction, we're talking about everybody dies on that island. Okay? So extinction for a species will likely go up as the island diversity also increases because everybody's competing. So that means ultimately, on an island, you have to have a balance between immigration and extinction. Does that make sense, guys? That's a key thing. So there has to be some kind of an equilibrium point. Looking at the size of the island and how far it is away from the mainland, you have to look at immigration and extinction rates. So somewhere in there has to be an equilibrium that's there. So this is when you see a curve like this, okay? Where we can look at the immigration or extinction. So our immigration, in this case here, this is the black line going down. And this is the number of species on the island. So the lower number of species on the island, we have a higher rate of immigration coming in. You have not a high rate of extinction. But when the island has many more species, you have much less immigration, but you definitely have a higher rate of extinction because the island can't support everybody. It doesn't have infinite resources. So somewhere those two curves have to meet, and that's it. This right here, where those two curves meet, that's your equilibrium point. Okay? That's the key thing. That's where your equilibrium point comes in. Okay. So if we look at it, continuing on, so smaller islands have lower total populations. That would make sense. If it's a small island, you're not going to have enough resources to support large populations. Okay? However, the chances, the probability of extinction does go up with a lower population. So smaller islands tend to have lower species diversity. They do. They just don't have enough to support everybody. Now, you have to understand something. When we say that a smaller island has lower species diversity, this is not necessarily a bad thing. This is just what is it that the ecologists and the environmental people are seeing? What is it that they're observing? This is a natural process. And we're trying to understand the dynamics of what's going on. Because remember, the Earth is a very dynamic place. It's not going to stand still. It's going to move. It's going to work. There's a lot of excitement that goes on with that. Okay? Okay. So now if we compare immigration and extinction for small islands versus large islands, okay, when you look at it, the extinction curve for the small islands is going to be higher. Just because of the size of the island, fewer resources, you're going to have more extinctions as you have more species on the island. So at some point, if we're comparing with the immigration, assuming it's kept the same, roughly, okay, what's going to happen is the number of species on the island for a small island is going to have a higher. It's going to be there at sooner. In other words, extinction's higher, you've got the immigration, so that equilibrium point is at a different location compared to the large islands. Okay? And here's like species per year, number of species on the island. But key things that you guys need to look out for. Large islands, they tend to have support larger number of species. Okay? Immigration goes down, extinction levels go up. Smaller islands, again, the immigration, it also is going to go down and the extinction levels are going to go up, but differently, at a different rate. Okay? So now, going further, islands further from the mainland have lower immigration rates. Now, why is that?
You cannot get there.
Yeah, it's a lot harder to get there. Okay? We've documented that some animals, they have gotten onto the island naturally by being on a floating piece of wood. Yeah, we have documented that. Okay? And of course, the further away the islands have, there's going to be a lower species diversity. They don't have the same exposure to what you have when you have islands that are closer. So if you're looking at something like Catalina Island, for example, it's a fairly close island. You're going to have a lot of species there. Although as humans, we've also impacted that. Okay? As we're winding down here, so if we look at the number of species on the islands, just looking at the distance, okay, the near islands, they're going to tend to have more species on the islands compared to the islands that are further out. So in wrapping up looking at it, there's some things that you need to pay attention to. The distance from the mainland makes a difference for the island, okay? If a large island is far away from the mainland, it's going to have fewer species than the large island that is closer to the mainland. This is also true for smaller islands. So, as far as fewer species, the smaller island that is far out from the mainland is going to have fewer species and less species diversity compared to the small island that's going to be close to the mainland. Okay? As we wrap up here for this. And with that, guys, that's the end of the theory of island biogeography. They don't talk about that in the book, which is sad, but I thought that was an important thing that you guys need to be familiar with. And with that, I am stopping here. And with that,